In this video we're going to see together how to post-read a CFD problem with LSPP4.3 and using the newly introduced CFD GUI and post-treatment tools. This is in LSPP4.3. Now the first thing I want to point out before I even start, well, is that LSPP4.3 is still beta. Okay, I'm using the version of January the 13th. So everything that I'm going to say and show here is still subject to modifications and improvements. So in order to access the new CFD GUI, you click here, you see on the bottom right here, you have something that's called MS for multi-solver. And then the first icon, ICFD, if you click on it, it pops this object tree right here. And what are those? Well, those are the different parts in our model. Okay, here we see we have shells, probably solid mechanics shells. Here you have MS shells, those correspond to CFD surfaces. And then we have MS solid, which is the fluid volume. Okay, why do we have solid mechanics shells and fluid shells? Well, this is because this problem was probably a fluid structure interaction case. Okay, so in this case, what are we starting here? Well, we are starting the flow around the car. Okay, well, where is the car? Well, if I want to show it, the first thing I'm going to do is, you see those boxes that are ticked here, I'm going to untick them all so I don't see any part anymore, and to only bring back those that show the car. Okay. Okay, so this is our object of interest here. Okay, but it doesn't tell me anything about the flow, and what I want to do today, I want to post-treat, I want to better understand what's going on in the fluid. Okay, so I can bring back the solid here. Okay, but this is a huge box, doesn't tell me much. Here I have some properties. It tells me that it's an 11 million element case. Okay, so that's quite a lot. It's quite a fine case, and we'll see later that has an impact on our performances, especially since I'm using just a laptop here. Here you have some display options. If I want to, I can color, for example, by velocity the whole volume, but again, that doesn't tell me much, right? Because everything that I'm interested in happens in that box, so I need to have a better access to that information. So the thing here, what I'm going to do, I'm going to untick the solid and then right click with the mouse on that object, and what I see here is that I have, certain options that start to appear: section, isosurface, streamline, vector, and then more advanced ones here at the bottom. So the first thing I'm going to do is I'm going to create a section plane. Okay, so now I've generated a section plane. If I select a section plane, I can change the normal, and I'm going to put it in the white. In the Y direction. Okay. Now again, if I click on the section plane, I have some display options here. For example, I can display the mesh. Okay, nothing surprising here. We see that the mesh is fine around the car. If I zoom in, I see that the user has used a boundary layer mesh. Okay, probably to better capture certain effects, the friction force for one. And then I can color that section plane. For example, I can color it with velocity. Okay, if I go back in shade mode, okay, here I see, okay, that here certain things seem to happen at the back of the car. Okay, it already tells me something. It already tells me some basic information. For example, but nonetheless important, it tells me here that the flow seems to remain attached. Okay, along the rear window, which is probably something that the user wanted to have. Okay, so already here I have a little bit of information. Another thing, if I right-click on the section plane, I see that I can, create some other objects. Okay, now for example, if I want to create some vectors, those vectors are not applied on the whole solid, but they're just applied on the section plane. You see here we have this tree hierarchy here. Okay, now it's a little bit of a mess. Okay, those vectors are very big. The first thing I'm going to do, I'm going to scale their length down a little bit. Okay, it's still a bit messy. The reason being is that, well, our mesh is unstructured and it plots one vector at every node, so obviously here we have a lot and we don't have many here, but overall it's hard to see what's going on, except that here we have something that's moving. What if I want to extract a velocity profile, for instance? Well, one way of doing that is there's a neat little tool here which is called grid mode. If you click on it, it's going to put the vectors in a regular spacing along the mesh. Okay, you can increase the density if you want to. Here, if I put 80 for example times 80, okay, there we go. Okay, you see here we have some regular spacing for the vectors. Okay, if I want to, I can untick the section plane so you see it better. Okay, here I can then extract some velocity profiles along a certain line. Where it becomes also interesting is that here we see, if I bring back the section plane, we see our fringe bar here, fluid velocity. Now the vectors themselves, I can also color them if I want to by something else. I can color them by pressure. What will happen? Well, it's a little bit slow. Again, it takes a while because it's a big computer and my big case, sorry, and my computer lags a little bit. So here now we have two fringe bars that have appeared, one for pressure and one for velocity. One is for the vectors here, vector block 21 refers to that object, and the other one for the section plane refers, colored by velocity, section plane 20 refers to that object. Okay, and I can move them around, pretty much can grab them and put them anywhere I want along the screen. Okay, if I want to remove the section plane, the fringe bar is going to also be gone. Okay, you have some more display options. For example, you can draw the vectors in shade mode. They appear a little bit better. Okay, you can play with it. But this is what I wanted to show you here. Of course, I've just drawn one section plane, but it's obvious that with this system, you're beginning to understand you can have more than one. Okay, you can right click and then create another section plane, which, let me see here, for example, if I grab it, okay, if I bring it down, further down, yeah, there we go, that'll do. Okay, for the moment. If I want to color, I can color it with velocity as well. And again, it gives me, now I have two section planes. They all have their own independent fringe bars. Okay, I can move them around, the two section planes, and color them by different variables if I want to. Okay, the key thing to remember here is that every point and every object that you create is independent and has its own options and properties. Now, real quick, what could I do here? What could I do? I'm going to really quickly show you the isosurfaces. Okay, you can create an isosurface on the volume. Here, for example, fluid velocity, magnitude. Let me change the magnitude. I'm going to do 10 here, for example. You see here that nothing has appeared for the moment. Okay, this is because doing those on those big models like this, several millions or tens of millions of elements, creating those isosurfaces, and you'll see it's going to be the same thing with the streamlines. It can take a while. Okay, so rather than constantly updating, which is costly, every time you move something here, you change something, LSPP Post is waiting for you to finish, to basically be done with your options. For example, if I want to color it by pressure, okay, and then you see here the isosurface is in red, which means it hasn't been updated. This information hasn't been displayed on the screen yet. So you right click here, you click on update, and then you'll see it's going to display the isosurface. See, it's taking a few seconds on such a big case. There we go. Okay, you see here I've colored this isosurface of velocity by pressure. Okay, of course the fringe bar here appears. It giving me additional information, right, on the flow. Nothing too surprising here. I see that there's some overpressure here, a little bit on the mirrors. Okay, and then I see here, this is probably where the main vortexes appear. Okay, here at the wheels at the back and a little bit at the rear mirror. Okay. Another tool which I want to show you would be the streamlines. Let's see what if I want to, how would you typically want to study, the flow that goes under the hood or close to the wheel, for example. Well, what you do is that you're going to generate a bunch of streamlines right in front of your object of interest and see where the flow is going. So here, just as an example, I'm going to right click, go in the streamline mode here, go plane. I'm going to draw a plane. I more or less know the coordinates by heart now. Okay, 0.8 minus 0.4, this will be 1 point. Then the other one, minus 0.2 minus 0.8. You see that as I'm doing that, on the left of the screen, right here, you see that it's drawing the plane from which the streamlines will be generated. Okay, and then here you see it's red again. That's because all of this hasn't been taken into account yet, because it first lets me pick how many streamlines I want. Let me see, I have 10 by 10. Okay, that'll be 100 streamlines. And again, if I want to color them, I can color them by velocity. Okay, then I'll right click and I'll update. Again, it's going to take a little while, a few seconds. And there we go. Okay, finally. So now we can take a look at the streamlines here that I've generated more or less, at the front of the car. If I look at it from the top perspective, okay, I see here the streamlines. Some of them have gone over the hood, here over the top of the car, and then coming down. Here you see that here there's a lot of noise happening, a lot of vortexes. Okay. So of course those that go around the wheel, they start to get lost here, start having some rotation. You see here there's also stuff that seems to happen. Okay. And then of course, since I put my plane in front and a little bit at the bottom of the car, most of them go under the car. That's what I wanted to study in the first place, and you see that some of them here get lost in the engine compartment. One of them here follows the shape of the car and the shape of the engine and goes on the other side. So all of this is useful information in order to better understand the flow patterns. You have also some display options. You can also draw the streamlines in shade mode if you want. This is for presentation purpose rather, visualization purposes. Oh, do I need to update? But one thing now, one big drawback with all the tools that we have seen is that they already didn't this work? Select the streamlines. Let me see here. Oh no, here that's what I wanted. Draw line as tube. That's what I wanted to do. Sorry, apologies. So here, there we go. You can see the streamlines in tube mode. Okay, which makes which is a little bit neater. One thing though, one key point here is that all those post-treatment tools that we've used, especially the streamlines, they usually imply that we already know, that the engineer or the user already knows a little bit about what's going to happen. Okay, for example, classically in CFD, when you want to post treat, people are going to do just what we did right now. Okay, they're going to say, okay, here close to the mirror, I'm probably going to have some vortexes. Okay, now if I want to start and try to better understand what's going on here, what I'm going to do, I'm going to put a bunch of streamlines in front of it, have them go over so I can track the flow patterns and the vortexes. Okay, then I'm going to do the same thing in front of the wheel and so forth. But it already, and then in the back. But it already implies that the user already knows more or less where the areas of interests are. Okay, otherwise he has to do this pretty much everywhere in order to understand what's going on. And he can miss stuff too. Okay, here this is a simple case, a simple geometry of a car, but it could be something more complex. What if there are vortexes that he simply doesn't see because it's so complex to see in a volume? He just misses them. Well, LS-PPost here offers a nice little tool. If you right click, you can ask for the display of the vortex cores. So here basically LS-PPost, this object, what it'll do, it'll draw a line through the center of the vortexes. So it'll allow you to immediately, for the user or the CFD engineer, to immediately spot, okay, here there's something of interest going on. There's some some turbulence, some vortexes. So you'll see that in a moment. There we go. Now we have the vortex cores. By default it's in line mode. Okay, so you see them here a little bit. I can put them also in tube mode, just like the streamlines. There we go. So now you see here, it tells you basically everywhere where there's a little bit of turbulence, where there are turbulence effects. Okay, obviously, as we have said before, you know, this is a car, so you always expect a lot of turbulence here on the wheel, then a little bit in the mirror. You see here the shape of the door also causes some tiny vortexes. Okay, here at the back, and of course at the back of the car. Okay, with two trailing ones. Okay, that keep going for a little while. Okay. This is a pretty interesting tool for engineers. Okay, you see here the engine as well. There's stuff happening here. It's pretty streamlined here, pretty much. Of course, okay, there's nothing. It's all flat, so something that you'd expect. So it's a pretty useful tool. What else? If I right-click here, yes, I wanted to introduce you really briefly the LICs. Okay. For line integral convolution. What this tool does, it allows you to it captures the flow patterns and renders them in an image that it draws on something that is similar to a sectional plane. So see here, for example, I've done it in the y direction. I see here I have some patterns here, some flow patterns close to the car. Okay, it allows me to identify, okay, some of the stuff that's going on. Okay, if I move it a little bit, let me go around the car, or at the back of the car, rather. Okay, now I'm at the back of the car. I see that the flow is almost smooth, save for those two little eddies that are at the back. Okay, so here we now maybe, I don't know, 3 or 4 meters, 12 feet at the back of the car, and we see that the flow is still not completely smooth. We see those two, you know, probably the consequence of those vortex cores, the trailing vortex cores that we have seen here previously. Okay. So all in all, this is what I wanted to show you regarding those post-treatment tools and regarding this object structure. I'm going to conclude with just a couple of things. How to extract some data. There's several tools that are available. One of them, which to my mind is the most interesting one, you frequently want to study the pressure along a certain line. Okay, here typically you would want to study the pressure along this line here. So how would you do that in LS-PPost? Well, you click on the shell object, which obviously, by the way, has its own variables here that you can display. For example, the y plus, which is very important if you want to study turbulence. Okay, here if I display the global values, for example, I see that the y plus, well, I got some very high values, but they're at the sharp angles, so it doesn't surprise me that the boundary layer does that. But here at the middle you have something that's between 30 and 50, which is probably for a RANS turbulence model. Then you can display the pressure. For example, you see that you have a higher pressure here, obviously, and so forth. But what I'm interested in right now is if you right click and create a data plot, and plot something by line, okay, and then if I want to extract the pressure along the x-axis, and if I select, I need to select 3 points, because if you select only 2, well, the solver, there's if I selected only 2 points, well, there's 2 ways that the line can go through, either underneath or over. Okay, if I want to make sure that it goes through, that it goes from here to here, well, I need to put a point in the middle. That's what P1 does. Okay, and then P2, if I select it here, okay, and X, yes, and if I update, and there we go. Okay, I have the pressure along this line here. Okay, I quickly drew it, but you can do something that's a little bit more precise. Okay, I have the pressure that goes along the car. So this is what I wanted to do. In conclusion, just as a short note, besides this whole tree structure, is that in the ICFD solver you frequently have some database keywords which dump some ASCII files. If you want to access them and to plot them using LSPP Post, it goes here. Okay, you have something that's called MS ASCII. You can, for example, load a drag file. Oh, there isn't any right now. Yeah, here there's one. You can load a drag file and click and plot the various variables. Okay, here I'm plotting the pressure force. Okay, in the x direction here you can see probably that the run hasn't converged because the value isn't constant. It's still moving. It's tending towards convergence, but hasn't quite yet. And then of course lift and so forth. So this is what I wanted to show you here. I hope you enjoyed this video, and I'll see you maybe later for another one. Alright, thank you.